All right, welcome Langley DeWitt. So we go way back. I guess it's been 2005. I'm not sure. I'm not sure when we first went to grad school, but we both went to CU Boulder. And fun story was we almost died going on a hut trip.
Yeah.
I think that's probably one of the top 5 times I thought I was probably going to die through lots of snow and avalanche. So lots happened since then. But why don't you just kind of give us a little background? So we knew each other in grad school at CU Boulder. And
Yeah.
so tell us kind of what you did briefly in Boulder for your graduate work, and then kind of what was your professional trajectory to where you're at right now.
Well, it's been sort of a winding professional road, but in CU Boulder, I did atmospheric and analytical chemistry, and I worked with Maggie Tolbert, and I did actually research on aerosols that would have been present on the early Earth when life was forming, and aerosols that are thought to be present on Titan, which is a moon of Saturn that's sort of thought to be an analog for what early Earth's atmosphere could have looked like before photosynthesis happened and oxygen became prevalent in the atmosphere. And after graduation, I wanted to sort of use my atmospheric chemistry knowledge to do something a bit more practical, a real world application. So I took an NRC postdoc, National Research Council postdoc with NOAA in Seattle. They have a branch there of the Pacific Marine Environmental Laboratory. We did research on air over the ocean. So I participated in 2 field campaigns, CalNex, where we measured the air off the coast of California, so clean marine background air, and also outflow from California of polluted air. And we also measured air in the middle of the Indian Ocean as part of Dynamo, which was the dynamics of the Madden-Julian oscillation, which is a intermittent weather event that causes a lot of intra-seasonal weather variability. So like if there's a dry day during the monsoon season or a rainy day during the dry season, it's connected to that. And we sort of measured 10 meters above and 10 meters below the ocean, all the conditions, the atmosphere in the ocean before, during, and after one of those weather events. So we just sort of sat there and measured.
Were you on a boat? When you say campaign, that sounds very serious. So were you like out in the ocean on a boat for a long time?
Yeah, so we were on a research vessel. So CalNex was just a month, and we stopped in LA, the port of LA, for a day. But we were mostly out, off the coast of California for a month. And then for Dynamo, we flew into Thailand, and then we took a research vessel that met us in Thailand to just a spot on the equator where they thought this weather event would pass by, and we just anchored in there for a month, and then we went back to Thailand for a port stop, and then went out again for a second month. Yeah. So that's what a field campaign is, just a lot of instruments on, in this case, a ship. And so after NOAA, I kind of wanted some international experience, and a 2-year research contract came up in France at the University of Aix-Marseille to measure air pollution in different regions of France. So we went to Chamonix and measured air pollution in the mountain valleys. We went to Corsica and measured air pollution, in the Mediterranean basin. So it was very tough to
really, it sounds awful.
be right by the beach. And we also did some laboratory measurement campaigns about like cloud reactions in cloud droplets that could lead to different formation of pollutants. And we did a microcosm study where we sort of had seawater in these bubbles in the Mediterranean Sea off the coast of Corsica, and we did different experiments in those sort of in situ in the seawater.
So were you looking at like primary pollutants, or were you looking at pollutants that then cause secondary kind of reactions? And then, what were there any particular pollutants in general that you were measuring, or?
Yeah, that's a good question. So for the mountain valleys, we were looking at 2 things. So France is sort of the opposite of the US in that they subsidize diesel fuel versus the US subsidizes non-diesel fuel, gasoline fuel. And so the idea with one of those campaigns was to measure right by a roadway, and they also collected license plate numbers of all the cars driving by, so you knew when like a diesel vehicle or a diesel truck was driving by versus gasoline cars. And so the idea was to try to tease out the primary pollutants from diesel. So that was the primary pollutant study. And also in the mountain valleys, there's a lot of wood burning for heating. People think it's greener than using electricity, but in fact, it causes quite a lot of primary pollution. So like smoke. So that was one reason for that field measurement. But then in the Mediterranean basin, we're a bit farther away from, primary pollutants. So it was more like we were measuring secondary aerosols. So secondary aerosols are when things are emitted, either gas phase or particle phase, and they react with solar light to form different species of particles, types of particles. And generally they're more oxidized, but yeah.
And so you, after France, you did another postdoc.
No, this was like a research scientist position.
Okay, so it was a research scientist. Okay. So we've passed the postdoc phases.
Yes.
Okay.
So it had more responsibility, which is basically, I think, the difference between a postdoc and a research scientist. And that was in Rwanda with MIT. So before I joined this project, the president of Rwanda, Paul Kagame, had come to MIT and asked if they could help sort of develop science and capacity for scientific research and knowledge in Rwanda. And so I wasn't very familiar with Rwanda before I moved there, but it's a country about the size of Maryland, and it's the most densely populated country in Africa, the first or the second, depending. So there's lots of people, not a lot of resources. So their sort of goal is to develop the people to sort of be a technology hub, a science hub in Africa. And so MIT proposed a lot of different things to Rwanda, the government of Rwanda, but one was to build this climate change observatory. So MIT and Scripps, University of San Diego, have a network of climate change observatories around the globe where they measure greenhouse gases, so carbon dioxide, methane, and also all the trace greenhouse gases that were recently regulated with a Kigali Amendment to the Montreal Protocol, so lots of hydrofluorocarbons and things like that. And so MIT proposed putting a climate change observatory in Rwanda because there's none of this type of measurements taking place in Africa at this time. The government of Rwanda agreed. Another scientist, Cal Potter, got it started, installing some instrumentation and doing the basic infrastructure, and then I took over to finish all the instrument installation. So something to measure methane, something to measure CO2, something to measure nitrous oxide, something to measure all those trace greenhouse gases. We also measured some air quality indicators as well, such as black carbon and carbon monoxide. And I did a lot of training of technicians on how to take care of the observatory. I taught a couple classes at the university and did some projects using low-cost air quality monitors to map air pollution around Kigali as well. And Kigali is the capital city of Rwanda.
So was the observatory in the city, or was it more remote?
No, it was remote. It was on Mount Magogo. So Rwanda's like the same altitude as Colorado, basically. So Kigali is at 5,000 feet, which is the capital, and then Mount Magogo was at 9,000 feet. So we put this observatory on the top of that mountain. And so the idea was to measure more background greenhouse gases and less like, car emissions and things like that.
Right. And then so after finishing with MIT in Rwanda, you went where?
So right now I am a air quality specialist at AECOM, which is a very large global consulting firm. So I'm basically consulting on air quality monitoring in the Houston area. And it's a big, air quality consulting is a big industry in Houston because there's a lot of industry here. There's lots of petrochemical companies, lots of oil refineries. There's historically been a problem with ozone in Houston, so there's lots of regulations on air quality and monitoring here. Yep.
So you went corporate kind of with the consulting.
Yeah.
But but now you've accepted a new position. Tell me a little bit about that.
Right. So I was a consultant for 2.5 years, and I did like it. It was nice to be out of academia and sort of doing a lot of small projects where you actually saw that you were getting something done at like a shorter time scale, I guess. Lots of deadlines, but I sort of missed the global community that I had built up with, all my various wanderings. And so I applied for and was accepted. Chosen as the director of the IGAC project. And so IGAC is the International Global Atmospheric Chemistry Project. So that's goal is to sort of facilitate collaboration between scientists, facilitate community, provide leadership in science, and talk about atmospheric chemistry to, the community as well.
That's great.
Yeah.
You're starting that up in a couple months?
Yeah, September. So we'll see how it goes.
Well, I have some questions from some of my students in my class. And so we'll do a couple of these. So let's see. Let's go with some. Okay, so we got some big questions. Okay, let's see. Okay, here's one. This is from Melissa. She asks, in being a scientist working on environmental issues, what ways do you try to influence people to improve the environment? And then she goes on to say, or ask, what are some of the things that are very important to you when thinking about environmental sustainability and such?
That's a good question. I always try to lead by example, carpooling, riding a bike if I can, shopping locally, not buying things I don't need. Another thing I think is really important is being somewhat politically active, because individual actions can't really add up to enough, I feel like, to help the environment enough to make a big change. Like, regulations are really important, I feel like, for environmental safety. So that actually is another question that someone brought up, is that, let's see. Natalie asks, what can we do as an individual to help improve air quality? Many people believe that personal contributions don't have any effect on our environment. What's your perspective on that? I think that's kind of defeating to say. I see both sides. I agree that there's a push to make it all individual contributions sometimes by maybe people that don't want regulations for their business, bottom line. And I do feel like individual contributions won't ever, fix the problem. And that's sort of pushing all the economic hardship that making these individual contributions would cause people, like buying locally is more expensive, trying not to buy fast fashion is more expensive, lots of different things are more expensive. So it's pushing that all onto the individual person, when really, like, regulations that affect, the laws on corporations and transport and things like that would make a bigger impact. But I do think that there's value in proving that there's a market for, greener products. There's a market for bike lanes. There's a market for buses. I think those are all important, and those are all things you can do individually. And it also just, it can be really nice to feel like you're making a small difference, even if there needs to be a bigger difference. So I think it's worthwhile.
So along those lines, so we've had this shutdown where people have, for probably longer period of time than any, stopped flying, stopped driving as many cars. Industries have kind of reduced their production. Have you noticed? I'm not sure about refineries in Houston, but have you been able or monitoring or heard of the air quality improving, or any of these kind of metrics for pollution changing with kind of this quarantine shutdown period?
Yeah, it's complicated, I think. But I know that in California, they've seen like quite a drop in different types of pollutants. In Houston, we've seen a drop in NOx, which is emitted from vehicles, and we've seen less ozone days, so high ozone days than we normally see. We've seen a drop in different types of volatile organic compounds versus, when there's lots of vehicles driving. So there's definitely been a drop in overall pollution. It is a bit complicated because things like ozone are formed in the atmosphere and they require the right meteorological conditions. Different types of pollutants can form ozone in different pathways. And so to say this causes that with the limited data that we have so far, I think is dangerous. But there's definitely been a noticeable reduction in pollution, especially near traffic monitors. Yeah.
Do you think that out of this, kind of as a follow-up, that there will be any data available down the line to say, hey, if we actually reduce cars on the roads or reduce air travel, that these can have lasting impacts, or is it just too small of a time frame to really be able to measure any of those impacts?
No, I mean, it's a few months, right? And so you can, and there's everywhere, right? So you can do statistics on a few months all over the world. So I do think that we'll definitely have the capability to analyze the effects of this reduced air traffic and reduced car traffic. And that'll be exciting to see, I think.
So do you think there are scientists out there, like this is a once in a lifetime, hopefully, kind of data collection period? Do you think there are a lot of people who are trying to get at some of that?
Well, yeah, there's already been a ton of papers published, and you can see like the submission to publication time is like 1 day, which is unheard of.
What?
Yeah.
That'd be nice.
Yeah, so I think that people are pushing papers out. Some of the papers might not have like the most rigorous analysis yet, but I think definitely within a year there should be some great analysis of all of the effects of these COVID shutdowns.
Yeah, it's very interesting. I think there's a lot of data outside of atmospheric chemistry too that probably can happen right now.
Yeah.
So here's let's see. What are the differences between the air quality? So Ivana asks, what is the differences between the air quality in the U.S. and Europe? Are there big differences?
Yeah, there are some. Europe has more NOx and sometimes more black carbon, and that's probably the diesel. There's a lot more diesel in Europe than there is in the U.S. There's more wood burning in different areas of Europe, and so that can be a difference. And those are the two big differences that I see, really, fuel use.
Now, are those pollutants, do they stay local in their effect, or once they're up in the atmosphere, are they moving around so that whatever is being thrown up in or put into the atmosphere in Europe is going to affect the U.S.?
Yeah, I mean, so black carbon lives in the atmosphere. Black carbon is like a type of particle that's black. So basically, if you look at soot, that's what I mean when I say black carbon. It can live in the atmosphere for 10 days, so it can definitely be transported. And there's some European papers that think that NOx from U.S. power plants are like coming over to Europe and affecting Europe. So there's some cross continent transport for sure.
Let's see, there was so the climate in East Africa, so Rwanda, and did that impact, or how did that impact your ability to collect data? Was there any kind of political aspect that you had to deal with?
Let's see. Well, Rwanda is very, like, they have a strong government. It's a pretty good government, but they don't love like quality control data to be pushed out, but they had no problem with my papers being published. They just needed, a Rwandan scientist as in the co-author, which is completely fair. You had to get a research permit to do research in Rwanda because they had some issues with scientists coming to Rwanda and then doing research and then never sharing that data at all with Rwanda. So they felt like they were being used, kind of, which I think I agree with. Like if somebody's going to come to you, if someone came to the US and didn't share the research that they did, people would be mad. So it's totally fair for them to do that the same way. I did feel, so Rwanda is great in some ways for gender equality. Like I think on the gender equality scale, with the different metrics like female representation in the government, it's higher than the US actually. But there's still some I feel like the laws for gender equality are high and the local attitude is low, like they kind of leapfrogged the local attitude. And I think that's fine. I think that the local attitude will catch up. But as a woman working as a boss for, all male technicians, sometimes I had some struggles getting them to listen, although that could have been cultural as well. Just me being an American and not understanding their culture.
Great. Let's see. We'll do one more. And this was actually a lot of people. So Royce had this and a couple others. Reese also, and Ismail also. So as a college student, what is the biggest impact that they can do on a personal level if they want to have to kind of slow climate change? So what would you say they could do? You've mentioned a couple already, but I'm not sure if you want to either say those again, or if there is maybe not a magic bullet, but something that they could do.
Yeah, I struggle with these questions because I'm not in policy. I do think, and I also love taking airplanes, and reducing air travel is like one of the biggest things that you can do to lower your carbon footprint. And I'm really bad about that. But if you can take a train and not an airplane, that's great. If you can live in a place where you can walk to your shops, that's great. And if you can sort of buy produce locally and reduce the things that you buy that you buy from Amazon, that also, I love buying from Amazon. Everyone a little bit does, but it's not great for the environment to ship everything to you. Yeah.
So all of the planes that get the things that you want.
Yeah, exactly. Yeah.
Yeah. So it's with all the quarantine, we're not driving anywhere, but we're getting everything driven or shipped to us. So.
Yeah. But it's still less driving, I guess. But yeah.
Well, I really appreciate you taking the time to answer some of our questions and kind of for the students in the class to be able to see like what a real scientist, an atmospheric scientist, looks like doing some of this cool work. I'm not sure if you have any like kind of last any kind of like parting words or kind of advice for anyone who's interested in this or wants to have a more impact than just at a personal level, or anything you want to leave us with. You don't have to, but if there's anything, could be you could share that.
No, I guess you shouldn't be scared to just try different things in your life and your career. Like if you're interested in environmental science, you don't have to feel like you have to be interested in a particular aspect of it forever, right? You should get a job that you're passionate about, see how it goes. It could lead to a next amazing thing that you would be passionate about as well. I've obviously lived and done many different jobs, so never feel like deciding that you're interested in one thing means that you're stuck doing it. You should just pursue what you're interested in.
And it sounds like you probably wouldn't have got your current job unless you did all your other ones before that.
No, yeah, exactly.
See, Mom, it was all worth it for something.
Exactly.
Well, it was great talking with you. It's been a while, and I really appreciate you sharing some of your experiences with us.
No problem.